Hello everyone, welcome to the session. So in this particular video, we will talk about an amazing interview based question which is very frequently asked in very much top based product based companies. So this question which I am talking about today, it's already been asked 79 number of times in a specific company called Facebook, and very frequently this question usually asked in Google and Amazon as well. So I'll talk about this question. Try to listen this problem very much carefully, and then step by step we will talk about the approach followed by the implementation of the same. And after that, I hope that this particular question, if suppose you will face in any of further upcoming interviews, you will be able to answer it very much aptly, right? So let's get started. What this question says is that you have been provided two numbers entered by the user. So those numbers are something, for example, there is A, which is a constant variable. Okay, so this is something which is a constant number, you can say. And then there is something which we have is N. Again, it is also a constant variable that we have. What we need to find out, as the name also suggests, we need to find out the power of an element. Meaning, if suppose a user will enter the value of A and N, then what he will be able to get as an output will be equals to A to the power N. Something like that. Let me try to give you one example over here. For example, I am saying that the value of A, which is a constant, is 2, and the value of N is something which is equals to 10. Right? Now here, as of now, the case which I am dealing with is that value of N is greater than equals to 1. So I am taking this scenario where I am saying that I am taking the value of N as greater than equals to 1. Now an interviewer can change the question afterwards by saying that now assume that the value of N can be less than 1 as well. So as of now, I am considering this case, and this is your part where you will give me the answer that when the value of N is less than 1, there is very minute change which is required at that point of time. You will tell me what change that will be, because I know that everyone knows here that how we can find the power of an element of a negative number as well. So let's first of all talk about the positive number where the value of N will always be greater than equals to 1. Okay, perfect. Now the output that we are expecting in this particular scenario for this particular test case will be 2 to the power 10, which is something which is equals to 1024. Correct, everyone? So here basically we need to find out the power of an element given the value of A and the value of N. That is the problem statement that we have. Perfect. So how we can do that? Now this is the next important question that we need to understand. So this is something which is an application of divide and conquer. This is something which is an application of divide and conquer approach. What this approach says? It simply says that what we can do is that if suppose we will be having a small problem, if there is a small problem, we can directly return the solution, right? Because the problem is small, we can directly return the solution. Just like in our real life, whenever we are facing a small problem, we can handle it on our own. We don't require any other person in our life to handle that situation. So similarly for the code, whenever the problem is small, it can return the solution pretty well. It doesn't require any divide and conquer kind of approach. But when the problem is big, now who will decide that the problem is big or small? We are the only one as a developer. We need to decide then when we can say that the problem is small. Obviously, when you can say specific to this particular use case which we are considering today, we can say that when the value of N is equals to 1, I can say that the problem is small at that point of time for this example. Why? Because when the value of N is equals to 1, at that point of time, the power of the element will be that number itself. So at that point of time, I can simply return the value as A. That's it. What does that mean? For example, I am saying 2 to the power 1. Answer will be 2 only. I am saying 4 to the power 1. Answer will be 4 only. I am saying 5 to the power 1. Answer will be that number itself. So can I say that this is something for my problem statement is a small problem? where anything to the power of 1 will be equal to that number itself, right? We can simply return the value as that number. Now, I am considering that when the value of n is greater than 1, that will be a big problem for me. At that point of time, what I can do is that I can apply this divide and conquer approach. So at that point of time, I can go for divide and conquer approach. Now, what this approach says to us? This approach says that divide the problem into various sub-problems until you reach to a small solution. Divide the problem into various sub-problems. That's why dividing part is coming into picture. This is what we usually do in our practical real life as well, right? Whenever we face some big problem or big trouble in our life, what we usually do is that, or what usually our parents say to us as a guidance, that is that divide your problem into various sub-problems and try to solve each and every problem step by step. Don't get confused. And that's what we are saying as a developer to the code, that don't get confused with a very, very high value of n. What you can do is that divide your problem into various sub-problems. For example, for this specific problem, what we can do is that, suppose I want to find the value of n is something which is equal to 64. Okay. So I want to find out the value of a is 2. I want to find out what is the value of 2 to the power 64. So what I will do is that I will split this problem into two halves, where what I will do is that I will try to do this n by 2. So I will try to find out the value 2 to the power 32 and 2 to the power 32. Now one thing you need to observe here, that this, if suppose I will be able to get the value of this number, automatically what I can do is that I can directly multiply the right side value, because suppose this value is, I am storing it in b. b is 2 to the power 32. So what you need to do in order to find out the value of 2 to the power 64, you just need to do the value of b into b, can I say? So there is no need to do the evaluation again and again, separately for the left and separately for the right. In this way, we can optimize our code in a more efficient manner, right? So what I can do is that I will do the further splits on the left side only, and will try to just multiply the results 2 times. I will do the multiplication 2 times, and that's where I will be able to get the power of an element. So what I can do is that it's still not a small problem, right? Because the value of n is as of now 32. So again, I will try to do the split. So here I will be able to get 2 to the power 16 and 2 to the power 16. Further, I will do the further split, because still the problem is not small. It is 2 to the power 8 and 2 to the power 8. So what I can do is, I am doing is that at every level, I am doing n divided by 2. This is what I am doing. So initially I was having 64. I was doing divide by 2. I was able to get the value as 32. Again, when I do divide by 2, it is 16. Again, when I am doing divide by 2, it is 8. Again, I will do divide by 2, it is 2 to the power 4, right? Again, when I will do divided by 2, it will be 2 to the power 2. Again, when I will do divide by 2, it will be 2 to the power 1. Now, this is interesting. Now, here if you will see, I am able to reach to a solution where the value of n is equals to 1. This is a small problem, right? Now, what I will tell to my code that just solve this left part. Just solve this left part, and I will simply multiply the same number with the right part. So what it will do is that it will give me the answer as 2, because we know it's a small problem and we already have written the code where the power is 1, return the direct answer as a, which is 2. Now what we can do, we can say that just whatsoever number you're getting, multiply that number, same number with itself. So 2 into 2 is 4, means I will be able to get the result as 4. Now whatsoever number you're getting as 4, multiply the same number again, one more time, because I know that on the right side, same kind of value is sitting there. So it will be 16. So 16 value I am getting for here. So now here if you will see, step by step, I am doing the conquering part. Here I am doing a conquering part. So when I am moving from the topmost part to the lowermost level, I am doing the dividing part. Now when I am moving from below to the top, I am doing a conquering part here. So now here if you will observe, 16 into 16 is 256. So what I am doing is that I am just multiplying the same number 2 more times because I'm not solving the right side. There is no need actually to solve it again, right? Because I already solved the same value on the left side. What I am doing is that I am doing some smart work here. I am just multiplying the same number again. That's it, right? And in this way, I will be able to reach to a solution where I will be able to get the value of 2 to the power 64. Step by step, you will move to the upper levels. I hope that I'm making sense to everyone. So let me write the pseudocode for the same. So what we are trying to do here is that the simple logic, very first thing that you need to understand is that we are saying that the value of a of n can be written as the value of a of n by 2 into a of n by 2. So what we are doing is that we are trying to solve for this particular part and multiplying the same number this again, right? This is the same thing that we are doing it here, right? So this is something which I can say is the recursive tree for above approach. This is something which is the recursive tree for above approach. Now, let me first of all write the pseudocode for the same, and then we will talk about the time complexity and the implementation part as well. So basically, if you will see here, what we are doing, we are finding out the power of an element, right? We are finding out the power of an element. Here we will be having the value a and the value n. Now, this is something that we have, which is entered by the user. Now, one simple thing which we need to firstly check out if the value of n is equal to 1 or not. If it is equals to 1, so here we are assuming that the n should always be greater than equals to 1. I am again repeating, this is the constraint which is given to us. Okay. Now, if it is equals to 1, it means it's a small problem. It means it's a small problem. And because it's a small problem, we don't even require the divide and conquer approach. Here we can directly return the value as a, right? Otherwise, this is important thing. Here, in else case, it means that it's a big problem. And if it is a big problem, means here we need to apply a divide and conquer approach. Here we need to apply a divide and conquer approach, right? What that approach is saying to us, it says that what I will do is that I will try to call the same function again, which is also known as the recursion, calling the same function again. So first of all, I will try to find out the mid value, which is equals to nothing but n divided by 2. And then what I will do is that I will just simply try to call the same function again, find power, but now with the value a and mid, right? With the value a and mid. So here we will be having a parameter now mid, right? This will keep on splitting and result I am storing here, right? Now one important thing here to understand. Here if suppose we will be having a value of n as even. At that point of time though it is fine. That suppose 2 to the power 64. It is even. So the approach that we are getting is perfectly fine. And you will be able to get a correct answer. Now when the value of n is odd, let me take a small example here. Suppose, so for even let me take the value of n as maybe 10. So which is an even number. So with the help of this recursive tree approach, you will be able to get the answer as 1024. Now when the value of n is odd, but still you are creating a recursive tree for an even number. So once you will be able to get the value of 2 to the power 10 using that recursive tree approach, what you need to do, you need to multiply that number with a. So you are multiplying that number with a to get the value of 2 to the power 11, right? Suppose you are solving for 2 to the power 11. So what is the difference between odd and even? For the odd number, you need to do one more time multiplication. You can apply the same approach that we have discussed, but one more time multiplication of a will be done, right? So that is the simple thing that we need to do here. So here we need to check that if the value of n modulo 2 is equal to 0. So this is giving us a guarantee that it's an even number. If it's an even number, approach is perfectly fine. We can simply return the result, right? Otherwise, in else case, it means that that's an odd number. If that's an odd number, we can simply return the value of result into the value of a. So one more time multiplication is required with respect to A. That is the only difference with respect to even or odd. So in this way, we will be able to handle all the numbers, whether it be even or odd, doesn't matter to us, right? This is the simplest approach to find out the power of an element when the value of number is greater than equals to 1, right? Now here, if I will talk about the time complexity part, now, so in order to talk about the time complexity, you should know about the recurrence relation of the same. Here, if you will assume that the recurrence relation will be T of n, so here, if you will try to observe it carefully for the n numbers, this part is something which is just taking a constant time, right? There is no as such loop is there. There is no as such recursion is there, right? For this part, if you will observe, we are applying a recursion here. So when recursion is happening, you are trying to split your data into two halves. So here, if you will see, the value will be something which is equals to T of n by 2, because you are dividing it by mid values. And after that also, you are doing some very simple comparisons by applying some if-else condition. So it is also equals to C. So in a nutshell, what I can say is that the recurrence relation for this particular code is something which is equals to T of n, which is equals to T of n by 2 plus C. That's the simple recurrence relation that we have. Now this recurrence relation you can solve either using the Master's theorem, right? Or you can solve this particular recurrence relation using a substitution method. So I hope that everyone is aware about the fact that any kind of a recurrence relation we can solve using basic three methods. Either we can solve that using a substitution method, or a recursive tree approach, or a Master's theorem. So here because here we don't have more than one recursive term, so we can either apply a Master's theorem or we can apply a substitution method to solve this recurrence relation, right? Very simple. So now what I can do is that let me apply the Master's theorem here. So to apply the Master's theorem, we should know the value of A, which is equals to 1. We should know the value of B, which is equals to 2. We should know the value of K, which is equals to 0. We should know the value of P, which is equals to 0. Now, if you know or aware about the rules of the Master's theorem, basically we need to evaluate the value of log of A base B here. So here, if you will observe, it is something which is equals to log of 1 base 2, which is equals to 0, because we know that log of 1 with any of the base, the value should be equals to 0. Now here, if you will observe, the value of log of A base B is exactly equals to the value of K, which is equals to 0, which lies under the case number 2 in Master's theorem, right? Now here, at that point of time, in this particular case, when the value of P is greater than equals to minus 1, because here we will be having the value of P is equals to 0. So the answer will be theta of n to the power K, which is equals to 1 log of P plus 1 into n. So here we will be able to get the time complexity of log of n. So if you know the Master's theorem, then only this part you will be able to understand. Those who are not aware about the Master's theorem, obviously they will face a trouble while solving this particular recurrence relation using a Master's theorem. You can also apply a substitution method. So see, if I will apply the substitution method also, I will be able to get the same answer. So how substitution method will work? It says that I will try to substitute the value of a recursive term. So here we will be having a recursive term which is equals to T of n by 2 plus C, right? Now here what we can do is that again we will be able to get T of n by 2 to the power 2 plus C plus C. So majorly what we are trying to do is that we are trying to basically what I would say replace or substitute the values of the recursive term. We all know that this is something which indicates a recursive term here, right? Now if you will try to do it for third time, you will be able to get n by 2 to the power 3 plus c plus c plus c. So here if you will observe, if I will repeat the same task until the value of a k times, where what is the value of k? N by 2 to the power k, which is equals to 1. So here the value of k will be equals to log of n base 2, right? So what I will be able to get? I will be able to get n by 2 to the power k plus k times into c. Because here if you will observe, when the value is 2, we will be getting 2c. When the value is 3, we will be getting 3c. So when we are repeating the same task k number of times, we will be able to get a k into c. So now here the value of k will be equals to log of n base 2. So it will be n by 2 to the power log of n base 2 plus k into the value of c. So here what we will be able to get, I hope everyone is aware about the logarithmic properties. Here what you can do is that you can just replace the value of n and 2. So you will be able to get n by n to the power log of 2 base 2 plus k into c. So in this way, you will be able to get the value as t of 1 plus k into c. T of 1 is something which is equals to constants 1 plus k value is log of n base 2 into c. So overall, you will be able to get the time complexity of order of log of n base 2. So this is the overall time complexity of this particular recurrence relation, or this is the time complexity of the approach that we have discussed of finding of a power of an element, right? So that is a very simple thing that everyone should know. Now, consider the scenario when the value of n I am saying can be less than 1 as well or equal to 0 as well. So for the case when the value of n is equal to 0, I hope everyone knows the answer should be, it should return the value as 1. This is a very simple case because we all know that whenever we are talking about any a to the power 0, the answer will always be equals to 1. This is what we all are aware of, right? What will happen when the value of n is less than 1? So I will talk about the logic of the same, but for the implementation part, I will give it to you. So when the value of n is less than 1, think over it. For example, I am saying that the value of n is equals to minus 4. The value of a is something which is equals to, suppose 2. So at that point of time, what you will do? You will, if you will be able to find out the value of a to the power n. So what I am saying is that this is the way to evaluate that, 1 by 2 to the power 4, right? So basically at that point of time, what I want is that a value is something which is equals to 1 by a. This is the first thing. And the second thing is that whatsoever the value of n you are getting, take a negation of that. So that if it is minus 4, we will be able to get a plus 4 here. And then whatsoever be the value you will be able to get, that will be the answer. So at that point of time, again, you will call the function which is find power. You can again call this recursion. So this is what you can return. You can call the function again find power by the updated values of a and n. And then the approach will again remain the same. So that is the only difference that you need to follow whenever you are dealing with a case when the value of n is less than 1, right? I hope it's making sense to everyone. If you know that how basically we will be able to do this particular part, then it will be very much easy, right? The case to understand when the value of n is less than 1 as well. So shall we start doing the implementation now? I hope that until so far whatsoever I have talked about. So basically we have discussed about the pseudocode or the approach first, where we have seen that how basically using divide and conquer approach, we will be able to solve this question. If the problem is small, we can simply return that solution. If the problem is big, we used to call the recursive function again and again until it reached to a small problem. So here what we are trying to do is that we are trying to find out the middle value, which will help us to give us the splits here. So here if you will observe, one time on the left side I will try to find out the value. Automatically I will do the multiplication 2 times and I will be able to get the number which is giving me the full-fledged answer, right? This is where we are doing the optimization part as well. After that, we have talked about the recurrence relation. I have showed you how basically this recurrence relation is created. And after that, using a Master's theorem or using a substitution method, we will be able to reach to a solution where we have seen that the approach that we have discussed in the above part is giving us big O of log of n time complexity, right? So let's talk about the implementation for the same. For that, I have opened the Jupyter notebook. And what I can do is that, first of all, let me try to write the driver code here. So here I will write the driver code, where what I will do is that I will take the value of a, which is equals to 2, the value of n, which is equals to suppose 10, right? And whatsoever be the result we are getting, I am storing that value inside the result variable. So finding of power of n, power of element, okay? And here inside that, I am passing the value of a and n. I can print the statement by saying that the power of an element is, and here you can simply mention the result value, right? I hope it's very simple. Correct, everyone? So here basically, if you will observe, we did the function calling. So if I did the function calling, obviously I need to define the method. So here I will do the function definition. Okay, so here I will do the function definition. So here I will call the function which I have defined, which is finding of a power of an element. So let me copy that. And inside that, I will first of all talk about the small problem. First of all, I will talk about the small problem here. So here what I can do is that if the value of n is equal to 1, what it will return? It will return to me the value of a directly. Otherwise, in else part means we are now dealing with a big problem. In the big problem, what we supposed to do? We supposed to apply the divide and conquer approach here, right? So at this point of time, I will try to find out the value of the mid, which is equals to n by 2 here. And after that, I will take the result variable where my result will be stored, where I will call the same function again. So this is something, let me write it in the above part. This is something which we called as recursion, right? So there is a recursive call which will happen here. So here I will call the same function again. I just copied that. So I will just paste that by passing the value of mid. Now I will check simply one thing, that if the value of n modulo 2 is equal to 0. So what this is indicating? That whether the number is even or not. If the number is even, what we supposed to do at that point of time? So at that point of time, the one simple thing, so if the number is even, we can directly return the result, right? This part also I have discussed on the blackboard pretty well. Otherwise, what I can do, I can, instead of returning simply the result, I will multiply it one more time with the value of a. I think this is quite fine. Let's try to run this code. If we find some error, we'll try to resolve it at that moment itself. So it is giving me the answer as 4. Why is that so? So return result. Otherwise, return the value of result into a. So mid is equals to n by 2. We did, so here if you will observe, I did something, I just forget something doing. What is that? So here what I can do is that, so here it is giving me only the one left side answer. But if you remember, we have discussed in our talk. Let me give you the justification. So one thing we forgot here, that is, I think in the pseudocode also I forgot, yes. So here if you will observe, this is something which is the result of the only one side data, which is B, right? But while explaining, I have talked about we need to multiply it 2 number of times to get a final answer, right? So what I can do is that result is nothing but is equals to B into B, not B. B is not the result. B is only the halfway we are talking about. So result is something which is B into B, and that's where we are going wrong. So let me try to now solve it again. Let me try to just rectify it. So it is now B into B because we need to multiply the same number one more time, right? To get that power. We have just solved only for the left side. I hope I am making sense to everyone. Now let's try to run it. Now if you will observe, we will be able to get the correct answer now, right? So if I will talk about 12, let's see, 4096. That's perfectly fine. But here I have just solved for the number. So here, if you will observe, I have talked about the finding of power of an element when the value of n is greater than equal to 1, right? Now what is your problem? So your assignment task for today is that just after listening this session, because I have already talked about the approach or the condition for the value of n less than equal to 0. So what you need to do is that take this file as it is. In this particular file itself, you need to add two more if conditions. One if condition for the value of if the value of n is less than 0, what will happen? Another if condition is that if the value of n is equal to 0, what will happen? And after that, your code should work even for the negative values of n. For example, if I will enter here the value of n as -4, so your code should give me the answer. So that is your assignment task. I think it's quite simple because I have already talked about the logic for the same. So let's see who will be able to give me the correct response for that. But I hope now I'm making sense to everyone. So here if you will observe, what is the overall time complexity for this approach? So because here we are calling the function only one time, we are calling a recursion only one time. So here the time complexity required to solve this solution will be order of log of n. And we have already talked about it a lot with the help of a recurrence relation and how we can solve it using a Master's theorem and the substitution method. So I hope that I'm making sense to everyone. If you still have any sort of doubt, do let me know, and I'll see you all in my next upcoming video. Bye bye everyone. Take care.